Okay, our second problem-solving technique, Chapter 2, is make a systematic list. Let's start with this problem. How many ways can you make 50 cents using dimes, nickels, and pennies? And as before, you should spend at least 15 minutes trying to solve this problem on your own before proceeding. More is better. But we'll assume you've done that by now. And try to answer these questions before moving on. Even if you've come up with a solution, think about these questions and work through them before going on to the next slide. So how many different choices do you have for the number of dimes to use if you're going to be making 50 cents? And for each of the choices of number of dimes, how many choices do you have for the number of nickels? So if you use 3 dimes, how many different options do you have for the number of nickels? And once you know how many dimes and how many nickels, how many options are there for how many pennies to use to get a target of 50 cents? Using these guiding questions, try to list all the ways to make 50 cents using dimes, nickels, and pennies. So try to finish the problem. Even if you think you've solved it already, see if you can organize it the way these questions suggest. Okay, so how many choices do you have for the number of dimes? Well, what we're using here is called a tree diagram. Over here at the left is what's called the root, and then here we've got 6 branches. So how many choices do you have for the number of dimes? Well, you could use 5 dimes, 4 dimes, 3 dimes, 2 dimes, 1 dime, or 0 dimes. So there's 6 different options for the number of dimes, everything from 5 down to 0. See how systematic that is. Once you know that you can use up to 5 dimes, all the rest just follows. Take away 1 dime at a time. Then, for each one of those branches, ask how many nickels you can use. Well, if you've got 5 dimes, you've already got your 50 cents, so you're going to use 0 nickels. If you have 4 dimes, that's 40 cents. You need 10 cents more, so you could use 2 nickels, 1 nickel, or 0 nickels. And if you proceed in this way, you get this lovely little mess. In red here, we've got, from the root, we've got 2 dimes and 5 nickels. Now 2 dimes is 20 cents, 5 nickels is 25 cents, so that's a total of 45 cents. Now the only thing you have left are pennies, so you know that from each one of these on the right, there's only going to be one more branch, one direction. So if 2 dimes and 5 nickels, what comes next has to be 5 pennies. So now if you count all of these nickel branches, you'll see that there are 36 total ways of making 50 cents using dimes, nickels, and pennies. We don't need to put the pennies in here because for each one of these, there's only one going off of it, determining how many pennies. So this tree diagram, students find it a little confusing at first. Sometimes they don't like it, they want to do it another way, which is always fine, but often students find after they practice and use these that they can be very helpful for organizing and keeping things systematic. Now here's another version of the answer. It's really the same thing, only in table format, and it's typed so it's more compact, obviously. So the 6 branches for dimes, I've color-coded them here. So here's the 5 dimes, and then all the ways with 4 dimes, 3 dimes, 2 dimes, 1 dime, and 0 dimes. So 6 different sections depending on how many dimes you use, and then for each one of those, all the choices for nickels. So either this or this is a good systematic list that lets you be sure that you've got everything and you haven't overcounted. Now let's go into a different problem, and it's easier, but it makes a point that I want to make. How many ways can you spend $4 on $1 chocolates and $2 chocolates? And the order doesn't matter here. So you're just buying some chocolates that cost either $1 for small ones or $2 for larger ones, and you've got a total of $4. And this is pretty easy, and you wouldn't need to use a tree diagram on this version of the problem, but if I ask you for $14, it might be a little more challenging. So if you have $2 chocolates, you could have two $2 chocolates. One $2 chocolate is 0. And then for each of those, well, the ones are determined for you. So there's 3 ways. Not a hard problem, but I wanted to ask a similar problem to make a point. And the similar problem is, how many ways can you add 1s and 2s together to get 4 if the order matters? So this time 1 plus 2 plus 1 and 2 plus 1 plus 1 are counted differently. So again, we can use a tree diagram, and I think here a tree diagram is going to be easier than a table. So your first number could be a 2, and then after that you could have 2, and that makes 4, so we'll circle it. Or if the first one's a 2, you could have a 1 coming after it. That's a total of 3, so the only thing that can come after that is a 1. But what if your first number isn't a 2? Well, then it's a 1. Well, after the 1, you could either have a 2 or a 1. If you have a 2, 1 plus 2 is 3, so the only thing that can come after it is a 1. That makes 4, so we circle it. After the 1 and the 1, you could have a 2, and that'll make 4, so we circle it. You could have a 1, and a 1, and so that makes 4, another 4 here. So we circle that, and so we see that there's 5 ways if the order matters. 3 ways if the order doesn't matter. 5 ways if the order does. Now, both of these problems are small, and you could do them without doing anything fancy. But if I ask you how many ways to make 5 or 6 by using 1s and 2s when the order matters, then it gets more challenging. So that's the technique of a systematic list, and we'll practice that this week.